Hi and welcome to video 3. This is the third of 4 videos for section 1.6, and in this video we're going to look at a bunch of examples. So we've been talking about limits as they approach positive or negative infinity. Now we'll look at some examples and see what values do we get as that happens. So the first one, we want to evaluate the limit as x approaches infinity of 3x squared minus x minus 2 all over 5x squared plus 4x plus 1. So at first glance, it's like, well, if I plug in infinity, that numerator is going to go to infinity. The denominator is going to become a real big number. That's probably going to infinity. So I have infinity over infinity. That doesn't tell me anything. So what we're going to do for the first step to actually get to a value of what does this limit approach is we are going to divide every term by the highest degree of x in the denominator. So, my highest degree of x in the denominator is what? X squared. So I'm going to divide every single term by that value. So I have the limit, as x goes to infinity, of 3x squared over x squared minus x over x squared minus 2 over x squared. Do the same thing in the denominator. So 5x squared over x squared plus 4x over x squared plus 1 over x squared. Looks like a big mess, but let's simplify it. So I have the limit as x goes to infinity. So in this first one, what happens? The x squareds cancel out, so I get 3. Here, one of the x's in the numerator cancels with 1 in the denominator, so I get minus 1 over x. And then this one stays minus 2 over x squared. And the denominator, again, the x squareds cancel from the first term, so I'm left with 5. I have the 4 in the numerator. One of the x's cancels with one of the x in the denominator, so plus 4 over x and plus 1 over x squared. So by the limit laws, I could distribute this limit to each piece, right? So the limit as x goes to infinity of 3 is what? It's just 3. Minus the limit as x goes to infinity of 1 over x. Well, like the property that I just gave you guys at the end of video 2, no matter what power x is raised to, a number over that, x to that power is what? 0. And the limit as x goes to infinity of 2 over x squared, also 0. The limit as x goes to infinity of a constant is that value of the constant, 5. The limit as it goes to infinity, 4 over x is 0. And again, 0, so I end up with what? 3/5. So the limit as x goes to infinity of this rational function is 3/5. So again, the key here was dividing every term in the function by the highest degree of x in the denominator. So we're not picking different ones. Oh, I'm going to divide the numerator by this and the denominator by that, because now you've changed the value of the function itself. So we're just picking the highest in the denominator, x squared, and then divide every single term by that value and find the limit from there forward. All right, we're going to look at another example. So I'm going to erase this. If you need to pause it to catch up or go back and look at some of the math, go ahead. So this one here, I want to find the limit as x goes to infinity of the function square root of x squared plus 1 minus x. So again, we've been trying to get to some point where as we plug in infinity, it's making the value go to 0. If we have a denominator with the infinity, we don't have a denominator here. So what can we do? We can rationalize this. So this guy is what? This is square root of x squared plus 1 minus x all over 1. If I rationalize it, it means what? It means I'm taking the conjugate of the numerator or denominator and then multiplying both numerator and denominator by that. So multiply the numerator by square root of x plus 1 plus x, and do the same in the denominator. So I'll give you a chance here. If you want to pause, try to do the algebra, do FOIL on the top, figure out the bottom, see what does this thing go to. If you'd rather just kind of follow along, that's fine too. So go ahead and pause if you want. If not, or if you paused and you came back, let's work this out. So if we FOIL this, we get first times the first, so that's what? Square root of x squared plus 1 times square root of x squared plus 1. So the root basically cancels each other out. Root times root gets rid of it. By doing the conjugate, when I multiply these two and add it or subtract it to these two, they eliminate each other. So I end up with what? Negative x times positive x, so I get minus x squared. Aha, look what we got going there. And then the denominator, what do we have? Well, we just have this guy, square root of x squared plus 1 plus x. So it's the same thing that I started with, limit as x goes to infinity of this, but now it's written like this. If I simplify this, limit as x goes to infinity, the x squared minus x squared cancel out, so I get 1 over square root of x squared plus 1 plus x. So now if I plug in infinity, what do I get? Well, I get a really big number here plus a really big number here. So 1 over infinity becomes what? 0. So the limit as x approaches infinity of this original function is equal to 0. All right, again, we'll look at another example. So I'm going to erase this. If you need to pause it, kind of follow back through, feel free. Maybe the only place I lost you was this conjugate. But again, if I multiply these two terms together, this gives me minus x times that. And the two ones on the end is plus x times the radical piece. So minus and a plus, they cancel each other out. And again, that's the whole idea of multiplying by the conjugate. Is on the FOIL, outside, inside, they cancel each other out. All right, I'm going to erase this, look at another example. All right, so let's say now we want to find the limit as x approaches infinity of sine of 1 over x. So, again, before we even get started, I'll give you the chance. If you want to try to work through it, try to figure out, all right, how are these limits applying? Let me go ahead and figure out from there. and see if you can come up with an answer for this one. All right, welcome back if you did try it on your own. If you didn't, that's fine too. So let's look at what's happening here. As x is going to infinity, looking at just this piece here with the sine function, 1 over x is going to what? Well, we already saw that 1 over x to any power is going to 0. So that means that the limit as x goes to infinity of sine of 1 over x is the same as sine of 0. So as x goes to infinity, this whole piece here, 1 over x, is going to 0. So I'm really trying to find what's sine of 0. And so, unit circle, pull it out. Or hopefully you have it remembered. Sine of 0, 0 radians, that's over on the right. Sine is what? How much up or down? I don't go up or down at all. So in this case, the limit as x approaches infinity of sine of 1 over x, again, gives us an answer of 0. All right, last example, which will wrap up video 3. So find the limit as x approaches infinity of sine of x. So again, give you a chance here if you want to try to figure this out on your own. As x goes to infinity, what does my value get close to? Or does it? My hint here, as I told you when we first started looking at limits at infinity, draw the picture. Because as soon as you have that picture, you can just look at it and say, oh, I'm out here at positive infinity. This is the value that is going to, if anything. So go ahead and hit pause if you want and try to figure it out. Come on back, we'll look at the answer together. All right, so as I said, let's draw this picture. I'm only concerned with x going to positive infinity, so I'm not going to worry about the left side of the curve. But sine looks like what? Looks like that, from positive 1 to negative 1. And this thing keeps going, right? Forever. All the way out to infinity. So as x is getting close to infinity, what's happening? This thing is just bouncing between negative 1 on the bottom and positive 1 on the top. So the limit is asking us what? The limit as x approaches this number gets closer and closer to what value? Well, in this case, it doesn't get close to any value. It keeps bouncing, right? So in this case, the answer would be does not exist. It's bouncing between negative 1 and positive 1. It never gets close to any value. It just keeps doing that forever. So the limit does not exist. All right, that's the end of video 3. Come on back. We'll do a little quick video for the 4th video, and that'll wrap up chapter 1.